This is lesson 14, part 2. We're going to start with evaluating functions. And evaluating functions, there's two ways that you can write evaluating functions. Regular notation, which is what we've always learned or always known, where it says y equals, let's say, 1/2 x plus 5 for x equals 4. Function notation is f of x equals 1/2 x plus 5. And then sometimes they won't put this x here. Instead, they'll put the number that they want you to evaluate x for. 4. So really, it's just a different way of writing it. The two problems are the exact same things. It's just a different way of writing. So here, we would take 4 and put it in place of x. Y equals 1/2 times 4 plus 5. Half of 4 is 2 plus 5. So we would say y equals 7. Over here, we just have to know that this means that goes in place of that. So when x is 4, we simply put 4 in place. We do the math the same way. It comes out the same thing. It's just that here we have it all together, and here we have to look two different places to find our x and y. So all it means is to take whatever this is and put it in place of your variable. So number 10. Find g of -3. So g of -3 means we're going to put 5 minus, and in place of x we're going to put -3. So first we have to do what's inside, which becomes 5 plus 3. We'll come up here, which becomes 8, and the absolute value of 8 is 8. So when x is -3, y is 8. Alright, so here, f of -4 means we're going to put -4 in place of x. Then we're going to do the math. -4 of -2, which gives us +2. So f of -4 equals 2. When x is -4, y is 2. Let's look at 4 ways to represent this function. Remember, a function is nothing more than an equation. That's just y equals. So symbolic representation. 2x minus 3. Y equals 2x minus 3. It's the same thing except we put y in place of f of x. Verbal representation. We could say 2 times x minus 3, or we could say 3 less than twice the number. 2 times the number is twice the number. 3 less than would be twice the number minus 3. Numerical representation, that means we put these in place of x, and I'm going to give them to you, and I want you to ask me about this in class. Where did I get these numbers? You're supposed to ask me that, so make yourself a note. So -5, -3, -1, 1, 3, 5. Okay, and then graphing them, -1, -5, 0, -3, 1, -1, 2, 1, 3, 3, and 5, 4, 5. So we can see here, if we did the vertical line test, we would have a function. Okay, 13. Same thing. Except they gave us the verbal representation. So we have to come up with the symbolic. So subtract 1 from. So that means we're going to say -1 from something. Half of the input to obtain the output. So half of the input would be half of x. And to obtain the output would be the equal. So symbolic 1/2 x minus 1. So now I'm going to magically get these numbers, and you're going to ask me tomorrow where they came, or in class where they came from. Then we're going to graph it. -4, -3, -2, -2, 0, -1, 2, 0, 4, 1. You can see that, yes, it is a function. The domain is the set of all x values. The range is the set of all y values. Consider the following graph of y equals f of x. So they're not really telling us what the function is, it's just that it's a graph. What is the name of this type of graph? It is a function because it's written in function notation. How do you know that this graph is of a function? If we do the vertical line test, it passes the vertical line test. Erase this. Now, y equals, this says f of -2. So that means x is -2. So we're going to look at x -2. What's our y value? If x is -2, y would be -1. If x is 3, y is -2. State the following, the domain. That's the x values. This x value is used, -4. This one is used, -2. This x value is used, -1. This x value is used 2. This one is used 3. This one is used 5. So all of those x values are used. Now let's look this way and see which y values are used. Negative 2 is used. Negative 1 is used. 0, 1 is used twice, but we only write it once. And 3. So negative 2, negative 1, 0, 1, and 3. So another view is doing it on a calculator. Use the table to evaluate the function. And this is what I'm going to show you in class, how to get the answers quickly. But this, we've already put this into the calculator, and this is what it pulled up. So if we look here, when x is 3, we look at 3, we can see that y would be negative 3. If x is negative 1, we see y is 5. If x is 5, y is negative 7. Use the table to find the intercepts of this function. Well, the x-intercept, y is 0. The y-intercept, x is 0. So here we can find the y-intercept is 0, 3. But we don't see where when x is 0, y is 0. But 0 would be somewhere in between these two, from 1 to negative 1. And so we're going to go halfway between this one, which is 1.5. So this is where 0 would be. And we would go halfway between here, which is 1.5. Okay, I'm going to stop the video here and then start a new one.